My name is Steve Jones, and I'm the Connected Curriculum Lead. This video is aimed at graduates who are considering different options for placements at Siemens. And in this video, I'm going to talk about Connected Curriculum, give you an overview of what it is, and also highlight some of the opportunities to work with me and Connected Curriculum over the coming term. I thought to start off with, it would be useful to give an overview of Connected Curriculum and explain what some of the strategies are behind this and what we're looking to achieve. To do that, what I'm going to do is show you a quick video which outlines just exactly that. It's a nice little animation, only lasts a few minutes, and then I'll talk a little bit more about what the opportunities of working together are.
Today sees us enter the fourth iteration of the Industrial Revolution. A period where physical objects seamlessly integrate into information networks around the world. AI, robotics, connected systems, and cloud-based platforms are transforming the industry in the same way that the very first machines revolutionized early manufacturing. Businesses are breaking down silos and seeing their businesses as complex systems where data, tools, and understanding run through all operations, from the supply chain to the wider user community. Those who work with physical products, be that design, manufacturing, installation, or commissioning, are shifting the way they work to suit this new, more complex and integrated landscape. Of course, new technology only makes sense when you have people who can make it work. Fortunately, the UK is home to world-class universities, many of which have produced leading innovators in critical disciplines. To make this a success, we need to bring academia and industry together so that students can learn in an immersive, collaborative way that sets them up for their future career. Take Emily, for instance. She's a talented undergraduate who has her sights set on a first-class degree and a career in engineering. She attends all her lectures and aces her projects. Her skills are second to none. Yet she is still unsure of how to put this theory into practice. How could leaders in education and industry help maximize Emily's university experience? We think connected curriculum is the answer. New technologies are transforming the way engineers work at an incredible rate. And while this is vastly beneficial to the industry, it means that graduates may find it challenging to hit the ground running when they step into the working world. Why? Because evolution is happening so fast. It means that learning materials need to be continuously updated in order to contextualize them. For leaders in education and industry, this is becoming a growing concern. With around 22,000 fewer engineers taking courses in the UK every year, and an increasingly competitive global market for talent, engineering is at a crossroads. Connected curriculum merges industrial practices with learning materials. Here, institutions are given the freedom to share and tailor industry tools, resources, and course materials to their teaching style. Industrial hardware and software are brought together in an off-the-shelf bundle that includes simulation environments, curriculum examples, case studies, and real-life problem-solving tutorials. This enables academia to become more creative, flexible, and collaborative. It also gives universities the edge when it comes to making the most of emerging technologies and innovations. The benefits for the education sector are clear. A stronger offer on employability, support for using the latest technologies, an open door for a closer partnership with industry, and a shared learning environment where institutions and academics can evolve with industrial innovation. Industry 4.0 is changing everything about the way we work. Connected curriculum makes sure education doesn't get left behind. Are you ready to show the next generation of engineers the industry of tomorrow? To find out more about connected curriculum, or to see how Siemens is dedicated to helping enrich teaching and learning, take a look at siemens.co.uk/education.
Okay, so I think that's great. We can see the strategy behind
what connected curriculum is looking to achieve and how we're helping to help our academic partners and university partners support the learners to be better prepared for what's happening at the forefronts of engineering technology, that Siemens see it, and the view that we have into the industrial world. So I think you can understand the strategy behind what we're trying to do there. In this next slide, we're going to talk about, okay, great, how do we actually help universities achieve that? What does it really look like? What is connected curriculum on the ground? Well, to demonstrate what we were talking about, the strategies before, we implement connected curriculum. When we do that, we actually use a piece of hardware which is made by Festo, an external company called the Festo CP Lab, and they make this great big kit, which the universities buy. There's no financial relationship between us and Festo. It's just that we direct the universities, suggest that they may want to buy this kit, and we build our connected curriculum model around this. It's like an integrated manufacturing cell, which is designed for education. So we build it around this Festo CP Lab. That's what we use, and we use this core bit of hardware because it allows us to demonstrate and to show different technologies, how they're used and how they all integrate together. So we have the hardware, the Festo CP Lab, and then we provide our academic partners with a bundle of software licenses. And this is really our Industry 4 software stack, a complete suite of academic licenses for these software. And then what we do is we build different models, different digital twins, effectively, of the Festo CP Lab using this hardware. So the software includes, and I'll talk about it in a moment, one bit of software is MindSphere, which you may have heard of. We add a MindSphere connection to the Festo CP Lab so they can see what that looks like. Then we build a digital twin using Technomatics, which is another piece of software which we provide them. We build a digital twin of the Festo CP Lab using Technomatics, or a virtual commissioning model using NXMCD of the Festo CP Lab. So we build models using the software of this hardware, and we show how all these different models interrelate. We then provide them with how-to guides on how to use the software. We provide them with case studies of different things that have happened in industry and our company partners, talking about how those technologies have helped improve their bottom line, how they've been really beneficial. And then we also provide lecture content. And this is either content we've taken from across the businesses or stuff we are increasingly creating ourselves. So we're producing lecture content, and that's one of the things that the graduates that I've been working with help me with. Okay, so what are the technologies involved? Well, we've already mentioned MindSphere is one of the products, really fascinating product that Siemens make, and we use that. We also use NXMCD, so that's what the virtual commissioning, which you may have heard about. That's what we use for that. We also include Technomatics, which we build our digital twin of Festo CP Lab, and also Mendix. Mendix is what's called a low-code platform. It's a way of writing code quite quickly without actually having to write. A lot of it's done graphically. So what kind of things would you be doing supporting connected curriculum? Well, if I give some examples of the kind of things that graduates have done, which hopefully will give you some view into the kind of thing you could be doing yourselves. One graduate who we worked with built a virtual commissioning model of the Festo CP Lab. Great, using an XMCD. And then he helped build a tutorial of how we'd done that, which we integrated into connected curriculum. And then he worked with some of the learners at the University of Sheffield and trained them up and explained them how they did it. And then they went and implemented their own virtual commissioning model. Another graduate helped us add the MindSphere connection to the Festo CP Lab, and she did a fantastic job and built some great resources which have travelled around the globe now. Those resources have had loads of interest from all over the world. She did a fantastic job. And likewise, she also worked with students at some of our partner universities and helped them understand MindSphere. Fantastic job. Another graduate then took the data from the MindSphere connection that she'd added to the Festo CP Lab, and then used Mendix, our low-code platform, to build an application which then presented that data in a really slick way. Another example, other groups have helped us create resources using Technomatics and the digital twin, and also built case studies of the ventilator challenge, and then we've integrated them into connected curriculum. So there's loads of different things that the graduates have helped us with so far. Done a fantastic job. So really, in conclusion, if you'd like to gain some great broad technical skills, and if you'd like to help the next generation of engineers understand what Siemens are developing at the forefront of engineering. And if you'd like to link in with other groups globally and help innovate some of these challenges, then we'd really like to work with you. The last thing though, whatever you decide to do, I hope you have a great time with your graduate placements, and I'd like to wish you the best of luck with them. I'm sure you'll do a great job. Okay, thanks very much.